So question number 4 is just asking us to think logically about why some of the answers that our calculator would give us make sense given what we now know. Namely that a log by default in the calculator is a log base 10, and that that's the base that the calculator is using when it spits out all of its answers. Now in question number 4, it's telling us something that we can verify in our own calculators to be sure. Log 6 is indeed 0.778 with a bunch of other decimals afterwards. And it just wants to know, logically, why is that answer smaller than 1 but greater than 0? So it really does go back to the idea that when you see log 6, there really is an invisible base of 10 sandwiched as a tiny little subscript between the word log and the number 6. So if log base 10 of 6 is actually the part that our calculator is doing, then hopefully your instincts to write this exponentially can make sense of why this works. If you think about this exponentially, we could translate that log expression very quickly to say 10 to the power of 0.778 is equal to 6. And since the question says, well, why is this answer, why is this 0.778 smaller than 1 but greater than 0? It's because 0.778 is an exponent. And if you think about possible exponent values that would make 10 to the power of something work, 10 to the power of something has to be 6. Well, yeah, 10 to the power of 0 would be too small. 10 to the power of 0 would be 1. And if the exponent was 1, 10 to the power of 1 is 10, which is obviously bigger than 6. So it kind of stands to reason that if I want to get a number to work as a power that would give me 6 as an answer, I need to find something in between these two extremes. 6 is between 1 and 10. So naturally, and I wrote this on the answer key this way, and I just wanted you to kind of see it. What we're kind of saying is that 10 to the power of 0.778 is naturally in between 10 to the power of 0, which is too small, and 10 to the power of 1, which is too big. So it's really just like saying, hey, yeah, you know what? We just need those exponents to kind of make sense. 10 to the power of 0 would be too small. 10 to the power of 1 would be too big. So 0.778 logically has to be somewhere kind of in between in order to get a value that is naturally in between. So it's not meant to be a super crazy question. It's just meant to get you to realize that when you press log in your calculator, it's just trying to find you the best exponent it can. So when you type log 6 into your calculator, it's trying to find the best possible exponent it can give you so that 10 to the power of that exponent will give you 6 as an answer. Since 6 is an awkward number, and since 10 to the power of something nice is never going to give you 6, that's why it's giving you a decimal, is because it's finding the best possible power it can, knowing that 10 is not naturally a power of 6, 6 is not naturally a power of 10, so it's going to have an ugly answer. When you do logs with nicer numbers, numbers that are actually factors or multiples of 10, then you'll get answers that look a little bit nicer. For example, log of 1,000, that's a nice number, because the calculator can easily find a nice exponent for 10. 10 to the power of 3 is 1,000, so the calculator has no problem finding a nice integer value for you. Log of any multiple of 10 is going to come out to be a really nice number, because generally speaking, it's going to find those exponents for you very easily and conveniently. Even fractions as multiples of 10 are going to come out to be nice integer values, because again, your calculator has no problem taking a base of 10 and finding a nice exponent for it. The issue is going to come when you have numbers that aren't multiples of 10, so like 247, for instance. The calculator is going to have to work a little bit harder to find a nice exponent for you. 10 to the power of 2 would be 100, a little small. 10 to the power of 3 would be 1,000, a little too big. So naturally the 247 is kind of in between, and that means it had to find you a nice exponent between 2 and 3 to be able to give you something that would make those numbers work. So that's the idea. The calculator's just finding exponents for you, and it can find it quickly. So that's the nice part about having access to a calculator. Speaking of finding exponents, questions 5, 6, and 7 are kind of the same thing. It's just asking you to write these in exponential form and to find an exponent that could get you pretty close to the number in question. So log base 6 of 29, it says x must be between what two integers? Well, let's think about what your calculator would be doing. Your calculator's not base 6, obviously, but your calculator's doing something similar, so let's think like our calculator. Our calculator's thinking exponentially. 6 to the power of something, x, would equal 29. So we're thinking to ourselves, well, 6 to the power of what would get us close to 29? 6 to the power of 1 is 6. That's pretty small. 6 to the power of 2 is 36. Ooh, that's too big. So if 6 to the power of 1 is too small, 6 to the power of 2 is too big, then that means x must be between 1 and 2. Because x is the power, we're talking about powers here, 1 is too small, 2 is too big, therefore x must be in between 1 and 2. So you can just think logically about exponents, and you don't have to like reinvent the wheel. You don't have to do anything crazy. Same thing in number 6. Write it exponentially. 3 to the power of x equals 625. And ask yourself, 3 to the power of what would get me closest to 625? Maybe you're not too familiar with your powers. Maybe you need to use a graphing calculator or some sort of calculator. 3 to the power of 1. 3 to the power of 2. 3 to the power of 3. And keep going and going until you're starting to get in the neighborhood of 625. You might need to start picking some bigger numbers. Once you figure out that 625 is probably going to lie in between two different powers, then you'll narrow down what x must be between. So x is generally just the powers that you kind of have to narrow it down to. One of them is going to be a little bit smaller, one of them is going to be a little bit bigger. So try those. Get the general impression that every time you're looking at a log, you're really just looking at exponents. That's all we have to train our brain to understand, is that logs are exponents. That's all we're really doing. So once that idea really does start to gel in your brain pretty well, the next page will build on that foundation even further so that we can start thinking about why we use logs. What are some problems in which using this skill will actually help us get somewhere in mathematics?